Hey guys, in this video I will be going over part 1 of what I believe are the 3 most important concepts for a beginner to master in blueprints. And the reason why I'm making these videos is that I've gotten a few friends and even a family member into making video games. And they've gotten into Unreal, they've started using blueprints, and while they've gotten a few of the basics down, when they want to go and make something new or when they want to do work, usually the first thing they do is they go to YouTube and they look up a tutorial. And while tutorials can be okay, I think they can be destructive if you are just copying them, because what they end up doing is they watch these videos, they copy exactly what the person is doing in the video, but they don't understand what they're doing or why, and then usually they'll run into some type of roadblock somewhere. They come to me, and while I'm looking through their code, I'll ask them why they did something a certain way, and they will just say, I don't know, that's just what the tutorial did. And I really think that's not useful. I don't think that's helpful, and I really don't feel like you are learning. So the purpose of these videos is that I want to try and give you a good foundation of how to think about your code, how to think ahead and plan, so that hopefully when you do get to a part where you want to do something new, you can think it through a little bit, you can get a general idea of what you want to do and how you want to do it, but because you are a beginner, you're not going to know all the tools that you have available to you, and that's where tutorials come in and they help fill that logic gap. But with the good foundation, while you watch that tutorial, you can start learning and you can start thinking critically about why they're doing what they're doing, and that's really what I want to try and help you guys with. So in this first video, we're going to go over the first concept that I think is important, and that is events. But before we get into that, this project is simply just the default standard first-person template. You can see the text right there. I have not touched this project at all, so if you want to follow along, you are welcome to. So the first thing that let's work through is, let's just say conceptually, I want to take one of these boxes and I want to make them spin inside of the world. Like, I want to make out an actor and I want to spin it. So where I would start is, I know my end product is I want to take a box and I want to rotate it. So to add some functionality, let's actually make an actor. And if I click inside of an open space down here, or if I even do add new, I can create a new actor. So let's create a blueprint class, and here we're going to select actor. Now as you can see, an actor is just something that exists inside of the world. It's something that can be placed or spawned in the world. It's just basically the most common type of blueprint that you will use, or type of actor that you will use, is just the base actor class. And here let's just call it cube. So if we open up our blueprint now, what we can do in the top left is that we can add a cube to it. So now we have our cube and we have our blueprint, and now with the blueprint we have some code. So if I knew I want to spin this cube in the world, I want to have it constantly inside of the world, just rotating. We have a few events available to us, and I guess if I take one step back, what I believe this first important concept is understanding these red events that we see here. The basis of all code, or the start of all code, is an event. You can't run code without having some type of starting point, to have some type of event to start it. So when I think about, I want something to happen constantly, I want this to constantly be spinning in the world, I know my end result. I know my end result, rather, is that I want to set the rotation of this actor. But how often do I want to do it? What is my event? Well, I don't want to, like, event begin play, that happens once at the start of the actor. I know I'm not just setting its rotation once, I want it to happen constantly. So logically, what I would say is event tick is your guy here. You could use something like a timeline or some other type of events, but really the main one that we're going to be talking about is event tick. Tick, if we highlight it, it says it's called every frame. I like to just think about tick as being 60 times a second. I believe it can be more, it can be less, but how I view it is this happens a lot per second. The exact amount I'm not quite sure some of the times, but here it's going to be happening a lot and it's going to be happening constantly. So when we hook this up, while I work through this project and I try and go through my thought process, I wouldn't worry too much about the math. The calculation part of this, what I would be more concerned with, and what I really want you guys to learn, is learn kind of the thought process. So personally, I just know that I want to get the current rotation of my actor, and I want to break it, and that what I want to do is I just want to be working with Z here. That is the yaw. I know I just want to constantly add to it, and that will spin the actor in the world. And if I make a rotator now, I can just hook it up. I don't want to touch the X or the Y. I'm not trying to change its pitch or its roll. I just want to spin it along its yaw. So here, what's literally going to happen inside of the world with our cube is that on tick, we're going to spin our cube. So let's try that out. So if we drag our cube into the world and we hit play, you can see our cube spins. And why that is that on tick, which this is however many times per second, we are running this code, we're taking it Z, and you can see we're adding 1 to it, and then we're setting the rotation. Pretty simple, but the key here is that it's on tick. If we put this on begin play, if we put this on begin overlap, any of these other events, it wouldn't behave the same exact way that we have it here. So it's very important to realize tick can be very powerful because you're doing it a lot, but at the same time, tick can be very destructive because if you're doing something expensive off of tick, it's going to be running a ton and your performance will probably start dying down. There are very good uses for tick and there are very bad uses, and as you get more familiar, you will learn how to stay away from the bad. But here, we just want to spin it constantly. Tick is our guy. So let's move to the next type of event. Let's use event begin play. And how event begin play works is if we highlight it, it says event when play begins for this actor. How I like to think of it is I like to think, when would the first event tick be of this actor? Here, it would be when the level starts. Since we have it dragged into the level, right when this level starts, on the first tick, event begin play would run. But let's say this cube didn't exist in the world. Let's say we spawn this cube 1 hour into our game. Well, the first begin play for that cube would be that 1 hour in, that mark that we first spawn it. So it's good to realize that event begin play is not when your game starts, and it might not even be when your level starts. It's when the actor has its first tick, whichever actor it is. It's when it exists, that first tick that it exists. So let's actually delete our cube out of the world, and let's use our level blueprint. So let's use the event begin play on our level blueprint. And we could either type event begin play, and we could search for it, or if you right click, you'll see that here that we have add event in our dropdown. And if we open it up, we can see that there's actually a ton of events. We can keep opening these boxes. And that's not all the events that we have available to us. When you start using more actors and different actors, you're going to get a ton of events exposed to you. So we're only going to focus on the main ones, but it's good to understand that events are the basis of our code, and they all have usefulness. There's always a time for one of these events to be used, and as you start to get more familiar, you'll start to be thinking in these types of ways that when you approach new code, you think, well, what event am I going to use? And based on some other factors like how often do we want to call the code, how are we calling the code, that will lead you to use different events. So here, what I want to do is at the beginning of the game, when our level first starts up, on the first tick of the game, let's spawn that cube in the world. And I know event begin play, that's going to be right when our level starts because we're in the level blueprint. So right when our level starts, we're going to launch this code. So let's spawn actor from class, and let's select our cube actor. So if we type in cube, we see that at the bottom here, and we can do our cube. And the one important thing that we want to worry about here is our transform. So a transform, if we do a make transform, you can see it's a location, a rotation, and a scale. I'm not too worried about the scale. What we really care about is the location. So if we click on our actor here, if we click on our first person actor, you can see its location on the right here. It's kind of weird. This isn't like we're at 0, 0, 0. Our root of our game is a bit offset and it's a little high. So what I'm going to do to get a location is I'm actually going to cheat. I'm actually going to take this text actor and I'm just going to kind of drag it up in the world a little bit, and I'm just going to take its location. So what I'm going to do actually is that if I have this text actor selected, so I physically have it selected, if I go back in the level blueprint, if I right click, I can get a reference to that text actor. And with that, off of it, I can do get actor location, and here we go, we have a location. And now when I hook this up, when we launch this code, we can read it as at the beginning of the level, we're going to spawn our actor at the location of that text actor. That's how we can read through this logic. So now if we hit play, you can see at the start of the game, we spawned our cube at the location of that text. And you can see it's spinning because on tick, if we go and look at our code, we can see we are constantly rotating it. So that's event begin play, and that is event tick. Begin play is often used for, say, if you're making like a first-person shooter. Usually what you'll do is on begin play, you'll attach your gun to the socket of your hands or something of that sort. Event begin play is really useful for maybe spawning a HUD, which actually let's do that right now. Let's create a simple HUD. So we can go in and we create a user interface and we can do a widget blueprint. All I'm doing here is I'm right-clicking in this open space, user interface, widget blueprint. Let's call this our user HUD. And now what we can do is with this user HUD. Let's just make it really simple. Let's just add text to it, and we can say this is a HUD. So let's say at the start of our game, when our player spawns, we want to create this HUD in front of them. What we can do is that we can go inside of our player. We can go inside of the code, the blueprint of our player. We can do that by selecting him, opening his blueprint. And then if we find our event begin play, we can search for it. We're going to enter. We can see it already exists. This code is just for use of I believe a VR headset. We don't really care about it, so we're going to unhook it. And what we can do is that on begin play, because right at the start of our actor existing, when our player starts, we want to create this HUD. We can do create widget. And once again, we're using begin play because we want this to happen right at the start. And actually, that's a little confusing. Let's actually rename that, so it's a little close to like the default name. Let's just call this HUD. And now what we can do is that we can do select class, and instead of having user HUD and user widget, we'll just call it HUD, and we can take the HUD and then add to viewport. Add to viewport is just how you put things to the screen, how you put widgets to the screen if we just want it to be like over top. So now at the beginning of the game for our player, we're going to create the HUD and add it to our viewport. So let's try it. And here you can see at the top of our screen, this is a HUD. And that's what begin play is really useful for. It's for when we know at the start of our game or at the start of our actor, it can get more complex than that. We want things to happen. Here, we're just popping up the HUD, or we're spawning the cube in the level. It's pretty simple. So let's unhook that so it's not in our way, and let's look at the next event we'll use. And the next one I think is good to learn is we will use overlaps. So there's a few different ways to use overlaps. You can use them in your level. If we go to all classes, I believe it's called a box trigger. So we can drag this into the level and we can use a box trigger, but let's actually attach it to our cube. So if we take our cube, we can, in this top left in our components, if we go to our viewport, we can see our cube. We can let's add it to our cube, and let's add if we go into collision, we can see we have some collisions. Let's add a box collision over top of it. I don't believe we'll be able to see it because it's very tiny, but if we up its extents, we can make it 100, 100, 100. You can see we have a decent size around our cube. And what we can do with this box collision is that if we have it selected and we right click, we can actually do an add event for our box. And what we can do is we can go under collision and we can do begin overlap. So add on component begin overlap. So here, if we highlight this, it says event called when something starts to overlap this component. Sounds useful. So what we could use this for is that when our player walks into this overlap box surrounding the cube, we can run some code. So let's add a little bit of complexity to our code, and let's actually make it so that we can stop this box from rotating when we want it to, or the cube from rotating from when we want to. So we can create a branch, and if we drag off of this pin, we can do promote to variable, or if we wanted to on this bottom left, we could do add variable. We want it to be a boolean, so we want it to be red, and we can call this spin question mark. Let's just ask ourselves a question. Do we want to spin? When I compile, what we get down here is we can change the default value. Let's set the default value to be true. So at the start of the game, we will be spinning, and that what happens is that on tick, so 60 times a second, we will be hitting this branch and we'll be asking ourselves a true-false question. Should we be spinning? If yes, let's keep rotating. If not, let's just not do anything. And then what we can do is down on our overlap box, so once again, when our player walks into this box, what we can do is that we can take this spin variable and let's just set it to be false. So let's try this out. What we can actually do is that we can actually make this not be hidden so that we can visually see our overlap box. So now, at the start of the game, on begin play, we spawn our cube, and let's actually do one more thing. Actually, I didn't want to add this complexity, but we're going to have to. What's happening is that at the start of the game, this is actually overlapping with the text actor. So with the overlap box, if we check its collision, this is going to be a little bit more complex than I wanted to get into, but very briefly, if we check the collision, we can see that it's going to be interacting with a lot of different things here. It's interacting with some world static, dynamic, pawn, vehicles, basically whatever's entering this box fires. Our issue is that text actor in the world where we're spawning the box is overlapping. So what we're going to actually do is we're going to take this actor reference that we have here, this other actor that we're overlapping, and let's actually cast it. By casting, we're asking, hey, when you overlap, this actor that we're overlapped with, is it something, like we can specify, is this, and we can ask, hey, is this our first person character? And what we can do is we can go to first person character, and what we're basically asking this overlap box is, hey, when this event fires, when something overlaps with our trigger box, is that actor is the first person character. If it is a first person character, we will run our code, but you can see we have a cast failed pin, and basically we're saying if that's not our first person character, don't do anything overlap box, just check to see if it is. We're not going to do anything if we don't want it to be. So now when we hit play, you can see it spinning, because what happened is it asked, hey, that text actor, are you our first person character? No? Then don't do anything. But now if we walk inside the overlap, you can see we collided with it just a little bit, it stopped rotating. That's because it overlapped. We said, hey, are you our first person character? It said yes. We set the spin boolean to be false on tick. If we actually do our debug for a cube, we can see the orange saying this is what's happening right now. Event tick, it's happening a lot. And we're asking, are we spinning? We set it to be false. No code is happening. So that's how we can use overlap events. I think overlap events sometimes are the easiest for beginners to conceptualize because it's really simple, right? We have this area, we can physically see it. Like if I hit play, we can physically see that overlap box and we can say, hey, if something enters it, let's run some code. It's really obvious, it's really simple. I would say beginners tend to overuse overlap boxes. In an end game, you actually, for me, I try to avoid using overlap boxes a bit because there are some performance concerns with them. But for beginner purposes, I think they're great and they're very good with feedback. It's really obvious between having like a yes or a no is something inside of it. I think the one hiccup that people tend to have is this overlap will run whenever anything enters it based on the collision settings. And we can see here in our collision settings, it's overlapping with everything. What we did is we did one more step to it and we said, hey, what are we overlapping with, that other actor? We're just making sure it's our first person character before we run our code. And that's kind of the check that you often need to do with overlap boxes. The next really obvious event, so we're actually going to unhook it. No, we'll leave it. The next type of event we're going to talk about is user input events. The most obvious user input event, for example, this first person game that we have, we can click, we can shoot. So every time I left click, we're shooting. That's also fairly obvious. What that is actually called is that's called an input action, or there's also input axis, but we're just going to focus on the input action. Here you see we have input action fire. There's a few different ways to navigate to where these inputs are. If you go to settings, project settings, or you can do file, or is it under edit project settings, there's a bunch of different ways to navigate to this. But inside the project settings, if we go over under input, you'll see up here we have bindings. We have our action mappings and our axis mappings. I wouldn't worry too much about the axis mappings for now, but for the action mappings, these are for single button presses. So we can see here we have the fire event, and if we check underneath it, you see that by default we have the left mouse button, or a gamepad right trigger, and a motion controller. So if we do any of these inputs on our peripherals, so on our left mouse, if we hit our left mouse button, we're saying that we want this event called fire to happen. So if we go back to our code, you'll see we have input action fire. And simply how you get to that event is if you just type in the name of the event. So if you type in fire, you can see we get our action events in fire. And what you do is you get two pins off of user inputs. You get a pressed and a released. So when we left click, the pressed will fire, and when we release, the release will fire. Here, if we simply look at the default code, we're playing a montage on our gun. That's really just for like recoil. We're spawning a projectile, which is that ball we're shooting, and then we're playing a sound. Fairly simple, right? So that really allows the player that we can check for inputs. We can say, hey, when the player wants to left click and shoot, we want to shoot something. It's fairly straightforward. I think this is also really easy for beginners to grasp because it's a lot like the overlap. It's very intuitive how they work. There's no like hidden magic behind it. So yeah, those are input events, and I think those fairly straightforward. When we want to receive input from the player to drive something, that's what we want to use. Like, we don't want to use like event begin play, right? We don't want to shoot a bullet at the first event of our actor. We don't want to use event tick. We're not trying to shoot every single tick of the game. So it's really intuitive that we want a user input. So let's set up a user input event. There's two more events that I want to go over, and they are custom events and functions. So if we go back into our cube, custom events and functions behave very similarly. There's a few differences. They're hard to really understand, or it's more when you get into complexity, some more complexity, that you start to understand the differences, but we'll go over them very briefly. But if we search custom event, you can see here that we get add custom event. Or if we do our drop-down box on add event, you can see it's right here. But you can notice how there's a different symbol on the left here. It's not open. It's not like blank within that arrow. There's some extra stuff there. And the reason being is that a custom event is a bit different from normal events. So it's an event with customizable name and parameters. So it's pretty cool that we can add a custom event, and we can name this, let's call it the spin event. And what we can actually do with this custom event is if we want to move our code off of event tick to spin, we can set this onto our custom event, and then what we can do is we can then call that custom event. So really, if you want to think about this like begin overlap, we don't really have like manual control over when something overlaps with our overlap box, right? That's up to like the course of the game, whether or not we would walk into that box. However, with the custom event, it's up to us when we want to call it. Here, we're calling that on event tick. And all you have to do is search for the name of what you named the event. We named it spin event, so if we search spin event, we can see we have call function and our spin event. And really, this is going to behave just like the code did before, because all we did is we moved the code off of event tick to our custom event, and then we're calling our custom event on tick. So really, nothing's going to change inside of our game. It is still going to spin exactly the same, and if we look at our code and drop down our debug, you can see the orange. On tick, it's constantly calling our spin event, and then here you can see it's constantly calling the spin event down below. So custom events are really just events when we want them to be called. This is a lot like how functions work. So on the left side here, you can see we have an area called functions. If we hit the plus button, we can have a new function, and then we can call it, if we want, spin function. But you can notice that we're no longer in our event graph when we work in a function. You can see how it puts us kind of in our own space. It's separated. A good way to kind of maybe conceptualize functions is that they are separated. They're kind of like segregated away from the rest of your code, and there's some good reasons for that. So what we're actually going to do is let's copy paste our spin code and let's put it in a spin function. And then what we're going to do is afterwards, let's delete this custom event that we're calling off of tick, and let's call our spin function. You can see we call that function just like we do with our custom event, or if we wanted to, we can take our spin function from the left side here and we can drag it in and just hook it up that way. Just like the custom event, this will behave almost exactly the same. We can open up our code, we can check our debug, we can see our orange is calling the function. If we double click the function and open it, you can see it's behaving almost exactly the same as the custom event. So that kind of brings into question, how do they differ? Well, with the event graph, you're able to work with timing. And what I mean by that is that we're able to use delays, we're able to use stuff like timelines. All of these things, they affect timing. Like we could delay our spin event so that we could delay it by 2 seconds before spinning. If we open up our spin function and tried to call delay, we don't get anything. If we tried to do a timeline, we don't have the node for a timeline here. That's because functions cannot be based on time. If you don't quite understand what that means, I wouldn't worry about it too much. You'll learn it over time, just on a very basic level. Understand you can't use delays or timelines inside of functions. You can use delays or timelines inside of your event graph, which is where you have custom events. So that's one very important difference. The other main important difference, I would say, is that if we open up our function, on the bottom left, you see we have this area called local variables. So if we make a local variable, you'll see that this is separated from our actual variables. We can call this, just for purposes, we can say local float. We can promote this to a float. And now with this float, we could get it, we can set it, we could change its default value, we can hook this up to our math and do stuff with it. But if you look at our event graph, you'll see that area disappeared. We no longer have local floats. And if we tried to like go in an open space and say local float, nothing pops up. The reason being is that inside of functions, we're able to make something called local variables. These are not global. These are not accessible everywhere. These are only accessible within our functions. So why would we want to use them? The main reason to me is for performance. And that is that at the end of our function, when it does its last piece of logic and it is done and the function ceases, it just stops, all of our local variables will get cleared from memory and they will cease to exist. So that means that if we like zoomed out and we had like a bunch of math and a bunch of calculations, we were using a bunch of variables, it could be very good to put that inside of a function and use local variables, because then at the end we can clear them out and that they don't exist and we clear them out from memory. Some things though, if we did go into our map, we're going to go over what I'm about to use here in the next video, and that is actor references. But if we went to our level blueprint, off the right side of our spawn, we get an actor reference to our cube. If we wanted to, we could set spinning. So that means that from our level blueprint with our actor reference, we can manipulate our cube. Once again, we're going to go much deeper with this in the next video, but if we did that and we tried to access that local float, you can see how, once again, we don't get access to it. So it's an interesting thing to note that if we want to be manipulating these variables, if we want to be working with them and doing some heavy stuff maybe externally, that might be a reason not to use local variables. Whereas with spin, if we want to change it somewhere else, that's why we would want to use a normal variable and not a local variable. So some interesting distinctions there. But I believe these are the most important events to at least understand. And if we really abstract this, we can really chunk code maybe into three pieces. You have a beginning, a middle, and an end. At the beginning, it's what event are we going to use? How often do we need to use this event? Do we need to be doing this on tick? Are we trying to do it constantly? If we go to our level blueprint, is this just something we want to happen once at the beginning of the game? These are some considerations and some things to think about. Next, you have your middle of the code. I like to just consider this like the calculation. Like here on the spawn, I just know that this is like the calculation. I know at the beginning I want this to happen once. In the middle, I know I'm going to be doing some type of math. And at the end, kind of the ending of our code, we have the beginning, the middle, and end. At the end, it's going to be our end node. Here, we're just trying to spawn an actor, or our end group of nodes. Sometimes you want to achieve multiple things. But when you approach new code, that's how I would really advise looking at it. What is the beginning? What events do I think I'm going to use? How often? Where do I want to do it? How am I going to call it? What event do I use? And then kind of C, I would probably jump to the end. What is the end result that I'm looking for? Here, I just wanted to spawn our cube, and then in the middle, we have our math, and it's just trying to figure out where exactly am I spawning that transform at. So that's how I'd visualize code, and what we just went over were events. I hope that was useful. And then in the next video, we're going to go over what I believe is the second most important thing, and that is what we briefly did in this level blueprint with this actor reference. We're going to go over how do blueprints communicate? How can I manipulate that cube inside of our level? How can I manipulate it inside of our player? How can we change things inside of our HUD at runtime? And that's actor references or object references, and that will be the next video. I believe all of these things are hugely important, and I really believe that this will help you understand tutorials. So I hope you stick around, and I can see you guys back in the next video.